Hello guys, this is Ashish here again. So we would be talking about replica set manifest files. So as with pods and other Kubernetes objects, replica sets are deployed declaratively using YML or JSON manifest files. If you are new to Kubernetes, these manifest files can be a bit complex and might take a lot of your attention, but there is nothing to be worried about. The following YML file is a fully working replica set manifest. It works with Kubernetes 1.8 and later requiring the apps/v1 beta 2 API. At a high level, it deploys around n number of replica of a single container pod. The pod is based on the image we have fed and listens to the port given. For version of Kubernetes prior to 1.8, you should replace the app/v1 beta 2 API with extension/v1 beta 1. You should also remove the 3 consecutive lines starting with selector, match levels, and app. So as you can see, you can see the entire program, entire code on the screen right away. As with the pod manifest, replica set manifest have 4 top level resources. 1. API version, 2. Kind, 3rd metadata, and 3rd is spec. It is common to use simple dot notation when referring to components of Kubernetes manifest files. The 4 top level resources we have shown are replica sets .api version, replica set .kind, replica set .metadata, and replica set .spec. However, we normally omit replica set prefix and simply name them .api version, .kind, .metadata, and .spec. So as you can see on the screen, it's a visual breakdown of the manifest into these four top level resources. Let's step through the file in a bit more detail. Now all Kubernetes manifest files start out by declaring the version of the API to use, which is .api version. Different versions of the API use different object schemas. This means the schema for a replica set in the API apps/v1 beta 2 API will have different properties and fields than the schema for the replica set object in the extension \v1 beta 1 API. Starting with Kubernetes 1.8, you should use apps/v1 beta 2 for deploying replica sets. For older version of Kubernetes, you can use the older extension /v1 beta 1. Now, the .kind find tells Kubernetes which type of object is being defined. In this example, it is replica set. Behind the scene, this makes sure the manifest gets delivered on the replica set controller on the Kubernetes control plane. The .kind field is always a string and is always written in camel case. The only required field in the .metadata section is the name of the replica set. In this example, we are naming it something. We can take it as per our choice. The name of replica set is a string and it has to be unique in the namespace. The replica set exists in the default namespace in this instance. You can add labels and other metadata in the section. The final top level resource in the .spec section. This is where the main configuration of the replica set lives. In our example, .spec .replica is declaring a desired state where 10 copies of the replica set's pod. Basically, it is 3 copies of the replica set's pod will always be running. This property is at the heart of replica sets. It is used when the replica set is initially deployed as well as during scaling and healing operation. For example, when you scale a replica set, you update the field. The .spec and .selector is new in the app's \v1 beta 2 API in Kubernetes 1.8. It lists the label that a pod must have for it to be managed by the replica set. In this example, we are telling the replica set to manage all pods in the cluster that have the label app given. So .spec.template is the pod template. It describes the pod that this replica set will deploy. This includes initial deployment as well as scaling and self-healing operation. For example, when scaling or healing, the replica set deploys additional copies of the pod defined in this section. The .spec.template.metadata.labels is a list of labels that the replica set will always apply to pods it creates. Now in this example, all pods deployed by the replica set will be tagged with the app label given. If you are using the app \v1 beta 2 API, it is vital that matches the replica set's label selector specified in .spec.selector. If it does not, the API will reject the replica set. Finally, .spec.template.spec defines the container that will run in the pod. This example is a single container pod, but multi-container pod have multiple .spec.template.spec container entries. So Kubernetes manifest files can be daunting, so nothing to worry about its complexity. It's not crystal clear yet. Once we go forward and cover a few more chapters, then make sure to come back, and you will understand more. Before moving on, it is worth noting that the pod template section, which is .spec.template in a replica set manifest, is exactly the same as standalone pod manifest. This is because replica sets create standard pods using the standard pod related API calls and endpoints. The only difference is that replica sets wraps pods in the blanket of self-healing and scalability, which is of great help to the users. So with this, being already completed this, I'm taking a pause right now, and we will talk and discuss more in the next lecture. Thank you very much.